Hi, my name is Kevin Cuello, and I'm going to prove that if a function is differentiable at a point, it is also continuous at that point. Now, we might want to remember what differentiable at a point means. If a function is differentiable at a point, then its derivative exists at that point. And if we want to prove if a function is continuous, we want to prove this. So this will be our starting point. Now we want to rewrite that circle expression in a different way for our convenience. So we're going to write it as follows. Now this expression is exactly the same as this, and here is the proof. So we rewrite f of c plus h minus f of c over h times h. Now the h cancel each other, and we're left with f of c plus h minus f of c. Now these two cancel each other, and we're left with only f of c plus h. And so we have this expression. Now we apply limits to both sides of the equation, and we're going to focus on this expression over here. Focusing on the underlying expression, we can separate it as follows, thanks to the property of limits that says that the limit of the sum of two functions is the sum of the limits of the individual functions. So we separate it as follows. The limit inside the rectangle can also be rewritten as follows, thanks to the property of limits that says that the limit of a product of two functions is equal to the product of the limits of the individual functions. So we separate it as follows. Now, we can identify this limit as the derivative of a function because that is the formal definition. Remember? This is the formal definition of the derivative. Since we identified this as the derivative of a function, and we're assuming that f is differentiable at c, therefore this is f prime of c, and this is f of c. Now this limit we just evaluated and is equal to 0. Retaking the original expression, since we did not work with this one, we can say that it is equal to f of c plus the derivative of f at c times 0. Now this product is equal to 0, so we're only left with this expression, which is what we wanted to prove at the beginning of the theorem. So we have successfully proved that if a function is differentiable at a point, it is also continuous at that point.